Welcome to Study Loop.
Let's evaluate the integral of 1 over x plus a times x plus b. Because a and b could be any real numbers, this problem will depend on whether or not a and b are equal, because if a equals b, for example, this means that we can write the integral as 1 over x plus a squared, and that'll change how we go about the partial fraction decomposition. This will be something that the book would call case 2. But really for us in this case, this basically is already in the form of a partial fraction decomposition. We just could actually go ahead and integrate this with the u sub, use the power rule. So this is why the case, it matters whether or not a equals b. And we'll see in case 2, when a does not equal b, we'll have two distinct linear factors in the denominator. So that's a different looking partial fraction decomposition than what we have over here that we're just circling right now. So first, we're in this case, a equals b. We rewrite the integral, and then you may be able to integrate it how it is in one step. But if this plus a is bothering you, just go ahead and do a u sub. Then you get du equals dx. So we could write this integral as 1 over u squared du. And then you could use the power rule to get negative 1 over u plus c. And then go ahead and replace u with x plus a. So in case 1, if a equals b, this should be the integral. Now we have to also look at the case in which they're not equal. So let's do this next. So that's case 1 all over here, boxed off in green. Now for case 2, a and b are different, distinct, not equal. So now we can go ahead and take the original fraction, 1 over x plus a. This form right here, as it's in, with a and b distinct, this is not a partial fraction decomposition. Here we'll be in what the book calls situation 1 or case 1, when the denominator has distinct factors that are linear. So we'll have capital A over x plus a plus capital B over x plus little b. Now, looking at this latest equation, let's circle this in black. Let's go ahead and multiply both sides by the denominator on the left, x plus little a, x plus little b. Go ahead and multiply both sides by that, and we should get 1 on the left, capital A times x plus little b, plus capital B times x plus little a on the right. Let's factor out an x on the right-hand side. We have a plus b. And then the constant term is capital A times small b plus capital B times small a. Now on the left-hand side, we see that there's no x term. This means that the x term, the coefficient of the x term on the right must be 0. And that's equivalent to saying b equals minus a. And then since the constant term on the left is 1, that means that the constant term on the right also has to be 1. And now using the fact that b equals minus a, we could come back to this equation up here and solve for large a. So let's factor out a large a here and divide. We get 1 over little b minus little a. And then since b equals minus a, due to this equation over here, we have negative 1 over b minus a. So I'm running out of room here. Let me go on to the next page. So the next thing that we'll do before we go on is we're ready to integrate. We'll take this original problem here. We wrote it in partial fraction decomposition, and now we just found a and b. So let's go ahead and plug in these values for a and b into the partial fraction decomposition. So this means that the original problem, let's write that out. And then we found large A, which is 1 over b minus a. That's the constant, capital A, over x plus a. And then we also found b. B was negative 1 over b minus a, all over x plus b. And these terms are easier to integrate. On the first integral, it might help you to do a u sub, u equals x plus a. For the second one, you can go ahead and take u equals x plus b to integrate these, and when we integrate, we should have 1 over b minus a, natural log absolute value of u, or x plus a, and then we have minus 1 over b minus a for the next integral. The minus is coming from this term up here. And then natural log absolute value x plus b, that's our integration. And then since this is a definite integral, we put in a c. The last thing to do here is just to simplify. We see that we can pull out 1 over b minus a from the first two terms. You have ln x plus a minus ln x plus b. Those are in absolute values. And then the last thing we can do, go ahead and use your log properties to rewrite this term in parentheses. We have 1 over b minus a, natural log absolute value, x plus a over x plus b, plus c, and there's our final answer.